For a tornado to actually occur in nature, conditions have to be just right. You need a cold, dry air mass and a warm, moist air mass to collide with atmospheric instabilities to create the vortex. The way it actually happens is the cold air falls and the warm air rises. And then once the warm air gets to the top, it cools off and falls, and the cold air at the bottom warms up and rises. So you get this rolling motion in the atmosphere, and eventually the instability will turn it up on its side, and you'll get the vortex that's the tornado. It causes all the destruction.
Hey guys, welcome to Weather Geeks. You just heard Dr. Travis Taylor, and wow, this is just an interesting guest today, and I'm so happy to have you. Thank you for joining us.
Hey, thanks for having me.
Before we get started, I have to run down some credentials. Listen to this, Weather Geeks fans. Dr. Travis Taylor, he grew up in the heart of Dixie Alley in northern Alabama. He has 3 master's degrees, 2 PhDs, and these are in things like astrophysics, electrical engineering. He's a rocket scientist and a fellow NASA guy, works for the, I think the Army now.
The Army now, right.
Has written 15 science fiction novels. He's a black belt, is in a rock band, and a pilot, and he's one of the stars of the new show, 3 Scientists Walk Into a Bar. Thank you for joining us. Tell us all about this show. What's that about? I mean, tell us about that, because the title's a little bit interesting.
Yeah, right, 3 scientists walk into a bar. Well, you think about it, if 3 scientists walk into a bar, what are they going to do? They're not just going to sit there and just drink beer and eat nuts. They're going to be talking about the stuff they do every day. And so we're talking about anything that could happen out there, because it is so amazing out there that you want to dig into every little thing. What I tell people I like to do is I like to tear things apart, so I can see what makes them tick, and then put them back together again.
Okay, so you're like a science MacGyver, so to speak?
Well, I don't know. I wouldn't go that far, but yeah, I would like to think that.
Yeah, but I mean, we saw in that clip there, you were talking about tornado dynamics, and so I know you have some shows coming up, the show May 31st or so, and I've seen some clips. There's some really interesting clips. You built a tornado machine. You're using fireworks to explain or test the theory about lightning and thunder. Tell us a little bit about some of the weather shows you did.
Well, we wanted to simulate a tornado so that we could show anybody the basis of how a tornado works. And I wanted to do it open air. If you look at tornado simulators, they're usually in a box, in a glass container or something. I wanted it open air so it'd be like a real tornado.
Right.
And it turns out it's not real easy to make a real tornado, but we ended up making about a 15-foot tall tornado. It hit speeds around 50, 60 mile an hour, and I took it to my daughter's elementary school gymnasium, had all the kids come in and had to make paper houses and cars, and we set it out and we rolled the tornado over it to show them what would happen, because all of them thought the debris would fly away, but it sucks it up into the vortex and then spins it out, and centrifugal force is what throws it away.
Now what about, lightning, a big hazard in weather? I mean, you've done a couple of things with lightning. So what about Tesla coils and fluorescent bulbs?
Well, the first thing is to simulate what lightning is, which is an electric arc, right? A very big electric arc. So we used a very big Tesla coil to show that we could make lightning jump, a couple of meters. But imagine, and that was millions of volts to jump a couple of meters. Now imagine jumping, 40,000 feet or whatever a lightning strike might do. That's an immense amount of power. But there's this thing that everybody hears as a kid or whatever. When it thunders, if you count, 1001. That's a mile before you see the lightning.
We teach that sometimes in our classes.
Well, but I wanted to make sure that everybody was doing it the right way. And so we used large mortar shell fireworks to simulate the lightning. And we set it out at known distances and launched the fireworks. And as it goes bang, you see the flash. And then we had a sound meter calculated from the time triggered when we see the flash to when we hear the sound at a known distance. And it turns out you need to count 5 seconds, not 1 second. Right.
So yeah, and I think the clips I've seen, it's just fascinating. I think Weather Geeks' audience and fans are really going to love the show. How do you go about selecting your experiments? And I know you don't just do weather. You were telling me about some things you've been doing, with various Earth.
It's all about from the center of the Earth out into space. Anything that's Earth related, about all these parts of the planet that are exciting and interesting and unique. One thing is about volcanoes. There actually is sort of a weather pattern underneath the surface of the Earth, right? And so we wanted to
there's convection down there,
right? So we want to do some experiments about volcanoes and explain why some volcanoes blow big piles of material into the sky and do devastation. Some just blow off the tops of the mountains, and some just kind of bubble out and roll down the side. So we did an experiment using the little balls, plastic balls like ping pong balls and so on, and we fill up in water vats and explosives. Actually, we used liquid nitrogen, and as it boiled and expanded, boom, it blows up. And so we would determine from different size canisters, how a volcano would react.
Now, one of the things I want to get into as you describe that, you use some interesting materials in your experiments. Some of them, let's say, have a little danger involved. Have you had any interesting experiences that you want to tell us about, or has everything pretty much been according to plan?
Everything has been safe, perfectly safe. Nobody's been harmed, and all of the experiments have been well thought through, so we didn't do anything that anybody could get harmed. Like when we do explosives or anything that could explode, like for example, freezing water in steel pipes, that actually becomes very explosive.
Sure.
And I'd calculated that you might have shrapnel that would be like a bullet.
Right.
So we built a bulletproof enclosure to do the experiment in, to make sure nobody gets hurt in the situation. And believe me, it makes quite a bang when a steel pipe goes pop because you had ice inside of it.
Yeah, I bet. Now, you do have weather and various earth sciences material on the show. Do you have any weather consultants or meteorologists involved, or are you just relying on your vast knowledge as a scientist?
Well, the other two scientists involved in the show offer up ideas as well, and then we've talked to Dr. Forbes, actually.
Right.
We've actually vetted some of our ideas through any of the folks here at the Weather Channel. They're interested in seeing it, and we get a lot of feedback, actually.
Sure, I bet.
Everybody's actually really interested because the experiments are fun.
Yes.
And that's the best way I've always found to demonstrate a scientific concept that may be esoteric or difficult to get your noggin around, is to make it fun so that everybody wants to watch. And make it have an exciting thing at the end, so you're going to hang in there until you see if it's going to work or not, which is the way science is.
Yeah, exactly, and that's really what we try to do on this show here. And when we come back, we've got a lot more with Dr. Travis Taylor. But next on Weather Geeks, no one can forget the Space Shuttle Challenger disaster. There was some really interesting weather-related phenomena associated with that. I'm going to talk with Dr. Taylor about that more after the break, but first, our Geek of the Week.
Hey Marshall, we've got not one Geek of the Week, but two, yes! Steve Ackerman and John Martin. They're professors in the Department of Atmospheric and Oceanic Sciences at the University of Wisconsin in Madison. Our geeks are known as the Weather Guys, yes, thanks to their monthly live-in show on Wisconsin Public Radio. These PhDs love the radiative transfer equation and quasi-geostrophic dynamics. But Steve also likes curling. And John, yes, he sings in a rock band. You know what? I used to be a part of that rock band too. A rock band called the Sundogs. How about that for a shout out? Well, congratulations to this week's Geeks of the Week.
And we are back, and you're getting two rocket scientists for the price of one. I spent 12 years of my career at NASA, but Travis Taylor, you did some work at NASA and for various federal agencies over the years. What did you do at NASA?
Well, I've done everything from high-energy laser systems to in-space spacecraft. My big thing is propulsion.
Okay.
Designing rocket engines and solar sails, like the one that's recently launched, right? And I've done, you name it. It comes to spacecraft. If you show a passion for it, you can get in there somehow, stick your nose into the tent and work on it.
Yeah,
right?
I want to take advantage of you. We were talking about, our weather geeks are familiar with this notion of not getting under an overpass if there's a tornado. And you had an interesting sort of propulsion-related sort of analogy to that. Why don't you tell us about that?
Right. Well, if you think about it, you always hear if there's a tornado coming and you're on the road, do you park under an overpass or out in the open? Well, if you're a rocket scientist, it should be obvious to you, right? Because the overpass is what's the throat of a rocket nozzle. So a rocket nozzle starts wide in the compression chamber and in the combustion chamber, and it gets smaller at the throat, and then it gets larger at the exhaust. And the speed is always fastest at the throat.
Yeah, exactly.
So the flow speed is right there. So why do you want to get in the place where the wind is going to be the hardest and the heaviest and the fastest?
Right, and I think this is a challenge of communication in our field often. Now, kind of getting back to rockets a little bit, everyone knows about the 1986 Space Shuttle program and the Challenger, or the disaster.
Right.
What was sort of an interesting weather angle that you've often talked about?
Right, I've researched this a lot in my career, and a lot of people think that it was just the cold weather causing the O-rings on the solid rocket motors to get hardened, and then they wouldn't seal off, and so you had gas escape. Well, what everybody doesn't realize is just a few seconds after that happened, some gas did escape, but then it welded itself back shut, right? But once it got higher up into the air, about 60 seconds or so into the flight, it hit a really hard shear layer.
Yeah, wind shear, so the wind speeds are changing.
250 miles per hour difference, right?
Yeah.
And at that moment, what some people have theorized happened was one of the bolts may have got hit by the gas at the bottom when it broke when it first launched and weakened the bolt. But that shear layer finally ripped it loose from one of the solid rocket motors, and then it hit the top of the external tank, punctured the tank, and then you have propellants flying out everywhere, and that's what ignited, and then that's what caused the disaster.
And so certainly weather, some hidden weather phenomena that didn't get as much press.
Most people thought it was just the cold air, but it was the cold air and the high winds aloft.
Now speaking of aloft and getting you write these science fiction novels, and one of your claims to fame is you try to have very scientifically accurate science fiction novels. I mean, and briefly tell us a little bit about some of your novels and your philosophy for writing.
Well, what I write science fiction, I've written, actually turned in my 16th novel just a week or so ago.
Yeah.
But the premise of most of my books are based in real science, real physics, that is then a speculation on what we could do with that, right? We have shown, for example, that in all of the aspects of general relativity, you could go faster than the speed of light if you manipulated space-time a certain way with like warp theory, like in
so we're talking about some
shows.
Star Trek type stuff here. So.
But you could actually do it, but in my books I would go through the details on how you'd have to get there. And go into it. You know, if somebody is going to jump off of a spacecraft and hope they're going to grab a hold to another spacecraft, well, I'm going to go into the details of the laws of inertia and action and reaction and all that so that it makes sense, right? And nobody's going to be poking holes at it, because science fiction readers are very good at nitpicking holes.
Right, well, and so are weather readers as well.
I imagine.
Well, and we'll come back next on Weather Geeks. We're going to geek out on a really interesting thunderstorm and lightning complex that we saw in South America. We've got some really interesting thoughts on this next on Weather Geeks. Now, how many of you have heard of Catatumbo lightning? It's a part of South America where the storms just produce frequent and almost constant lightning. And some of the theories associated with this particular lightning have ranged from warm, moist water over warm lakes to what we call orographic lifting, or lifting up over mountains. But Travis has another theory that he thinks might be at play. What are you thinking?
Well, in this region, there's a lot of uranium being detected, and radon gas as a decay product of that. And when you have decay of radioactive material, you have gamma rays and so on that enter the atmosphere, and it changes the electric field constants of the atmosphere, which would make lightning more likely. Right? It's like when lightning is actually more likely to strike in the same place twice because you create a pathway for it. Well, I think this whole region is a good pathway for lightning.
A big, large ionized sort of area. And I've seen some studies in the geologic literature that suggest that as well. So it's really an interesting theory. So if you haven't really seen that lightning, Google that out there. And I know we were just showing you some really interesting clips, just really fascinating. I want to come back a little closer to home, because you grew up in northern Alabama. We've had James Spann on talking about the outbreaks and tornadic storms a couple of years ago. But there's really some data and even your own personal experience that suggests that this so-called Dixie Alley, and particularly northern Alabama around Huntsville, might be prone to tornadoes?
Oh, well, I can tell you from personal experience it is. I was 6 years old when the super outbreak in 1974 happened, and they were all around where I lived then. And then in 2011, 3 tornadoes passed within a mile of my house in one day, in like 8 or 9 hours.
And many of these have been EF5 level tornadoes.
That big EF5 that was on the ground for like 132 miles missed my house by 1/8 of a mile. It tore the back porch off my house and threw it through the roof. And houses next door, like just 1/8 of a mile away, there was a path a mile wide that was just gone.
Wow, and yeah, we're seeing some of the footage there from some of these storms, and yeah, you can see the tornado history there in Huntsville, right. Rocket City, USA. Right. It's really interesting, this sort of mini tornado alley, if you will. And in fact, there's an upcoming Vortex Southeast, a big federal program. Most of these have been out in the Great Plains in the Midwest, but researchers are coming to the South to look at storms, and I think they're going to kind of maybe park in one place. It's kind of tough to chase in the Southeast, right. But certainly some of your anecdotal and even more experienced information suggests this is a good place to come study tornadoes.
Right. Well, from that track, you can see just park your equipment in one place. The tornadoes are going to come to you.
Yeah, and you know, there's research out there, and certainly there's more research that's needed. Now,
sure.
Yeah, you know, as we kind of, I mean, I think this is going to be a really interesting show. The clips that I've seen for 3 scientists walk into a bar, you know, hopefully it's clarified a little bit to some of our viewers, because it really is a science show. It's got some good weather and geosciences information.
It's going to be a lot of fun.
What would you offer to those that might want to sample your show?
Well, I'd first say if you want to see some clips and some more about the 3 scientists, go to the 3 Scientists Facebook page.
You have a Facebook page right now, yes.
Go there and check it out, and we have clips. It's really fun. We've got some experiments, and we put new stuff on there every day. Like just last night, I made a fire-nado and filmed it so it'll go on there at some point. You can see how that works.
And certainly fire-nados are very much a part of wildfire weather and some of the things we see, and with the dryness out in the West, I mean, that's certainly relevant. Now, when does the show air?
May 31st. They're going to run 3 episodes that Sunday night.
And will any of those episodes be some of the weather-focused episodes?
Oh yeah, I think all of them are.
Okay,
actually.
So they're all going to
be the tornado, I think, and then lightning, and the experiments that I talked about with the fireworks and so on.
Yeah, and in this last 30 seconds or so, Travis, what do you tell kids when you go out and I bet you speak to kids quite often. What's a message that you leave for kids?
Well, I always give them 2 things that I want them to walk away from. And one is how amazing the universe is. I want them to go and dig into it, and don't be afraid to take things apart and put them back together. Sometimes that won't work right, but that's okay, as long as Mom and Dad gave you permission.
Sure.
And then the other thing I always tell them is that the dinosaurs didn't have a space program. Because I want them to realize that.
Yeah, that's a great point. I've seen Neil deGrasse Tyson talk about that.
Right.
You know, asteroids are nature's way of warning us about our space program.
That's
and how
exactly right.
So yeah, but you know, we want to thank you for coming on Weather
Geeks.
Welcome back anytime. And Weather Geek fans, if you have feedback, you can always follow us at our Twitter site, and we also have a Facebook page as well. You see those on the screen. Join us next week on Weather Geeks.